Morning, bore da. Croeso I Cardiff. Welcome to Wales for PYCON UK. My name is Tom Crick. I'm Professor of Computer Science and Public Policy at Cardiff Met. And I've been involved in a lot of the curriculum reforms, I suppose, over the past kind of 6+ years. Primarily in Wales, unsurprisingly, but obviously the bigger picture of computer science education and in particular discussions of the coding curriculum and kind of what that entails. So I'm going to give you a bit of a skim through of what's been happening over the past few years and then kind of place it in context of the rationale for what's been happening, some of the challenges, some of the opportunities, particularly with we're kind of supporting the teachers as this curriculum has unfolded in England, a little bit of stuff we're doing in Wales, and then I suppose looking ahead to the future, and hopefully we'll have some time for questions at the end, so please feel free to jump in. Excuse me. So there's been massive focus on getting kids coding. Sorry, I can't find a Python one of this. Obviously, everyone's happy with the kind of the classic Kernan and Ritchie C book. But this has sort of dominated discussions of the computer science curriculum reforms. I mean, certainly in the UK, but internationally, this seems to be the kind of default language for talking about high-value digital skills, getting kids coding, digital economy, this is the future of the knowledge economy, this is why we need all of our kids to be programmers. And this has been quite a painful message sometimes because it doesn't quite map to what we're trying to do or what is happening. And also it means it's quite easy to critique or criticize some of the reforms that have been happening across the UK. The sort of stuff saying not everyone needs to be a programmer. It's like, yeah, well, of course, that's not what we're trying to do. We don't try and turn everyone into mathematicians by teaching them a bit of algebra and calculus, but it's the ability to kind of understand and frame the world in which they live. But the problem is terminology has been a massive problem over the past few years. So, I don't know how many of you here have formal qualifications in computer science, ICT, software engineering, software development, IT, information systems. There is a multitude of terminology, there's a multitude of quals that kind of sit in this space. And this has been quite damaging and confusing over the past few years, particularly in the UK where there's been a lot of focus on ICT as a subject at school. And as that's kind of evolved and moved into computing or computer science. But wars have been fought over terminology. It seems, I suppose this is a epistemological kind of approach, or maybe this is just computer scientists, or this is just academics in general. But the idea about moaning about terminology, or there's real kind of culture clash and an affinity with certain phrases with some of these terms. So we have to be really, really careful about what this means. And there's a lot of identity, particularly with teachers who are, if they're ICT teachers, and suddenly politicians say ICT is crap, that's not good for the teachers. So we're trying to manage some of that messaging. There's always, you can find quotes on the internet, but this one is a genuine one because I've spoken to Hal Abelson, he's an MIT computer scientist. He definitely said this. I confirmed this when I was in Hong Kong in July. So this is, the idea about there's a mismatch between terminology. In the panel session yesterday, there was a comment saying, let's not call it computer science. This isn't a great phrase. A lot of academics think that too, but maybe anything that is named science isn't a science, but actually, this is not. People hear the computer and not the science. So that's also been quite challenging for the discipline as it started to appear in schools. This is quite interesting. If you do this for kind of Google autocomplete, do this for other subjects. Do it for maths. That's a cracking one. But, there's some interesting stuff here. Computer science is hard. Yeah, that's right. There's no worries with that. But computer science is not programming. That's kind of an interesting thing about it's not engineering, but just kind of understanding, I suppose, what people have Googled before, or kind of maybe provides insight into what people are Googling about computer science. Just to remind you, welcome to Wales. There are 4 nations in the UK. There are 4 education systems in the UK. And actually, there's increasing divergence between all 4. So largely, we're going to talk about England in this for some of the curriculum reforms, just because it's been, well, as you can see, kind of largest by population and land mass, but in the sense of that it's the most kind of entrenched curriculum at the moment. But actually, it feels like, particularly in Wales, Wales is going to be kind of the curriculum is evolving much more like it is in Scotland. But this is also another bone of contention when you hear people talking about the UK curriculum or the UK's education system, because there are 4 and they are getting increasingly different. So I'm a computer science academic, but I'm sort of representing CAS. So if anyone, who's a member of CAS? Fantastic. Well, it's free to join, so don't feel like I'm going to get any kind of bonus or commission. But this is basically, Computing at School is the Subject Association for Computing. It's an organisation that's basically been trying to promote computer science education and support its implementation across the UK and increasingly internationally. So this is a kind of a grassroots community of people of every kind of demographic who care about computer science education in UK schools. So please feel free to join. It's actually, you don't have to be an academic or a teacher, or you just need to care about this kind of stuff. So we've been working for quite a long time to make this happen. So this has been probably since 2008, where the early CAS members have sort of got together and started to try and kick some of this stuff around because of the perceived problems with the curriculum. As you can see, there's always a nice graph. You can see the kind of CAS membership. And the reason why I've put this up is because a number of interesting things happened around kind of 2011, 2012 from a policy perspective, and suddenly you can see why a lot of teachers started becoming members. So this is basically when in England, Michael Gove, the then Minister of Education, he might be coming back at some other guys soon, he disapplied the programmes of study. So he basically said ICT is not fit for purpose. Then in January in 2012, the Royal Society published a very influential report about computer science education, and suddenly we've seen this kind of, exponential-ish type growth. But basically there's a lot of people who are deeply interested in what's happening in UK schools, but also there's a massive community of teachers. So the overwhelming majority of CAS members are teachers. So this is the community for teachers to get together and help and support each other. So ultimately, there is a lot of fear, there has been a lot of fear and uncertainty with what's been happening in schools. And I like to think kind of CAS has been the place for kind of teachers to get together. And that's been sort of a distributed model. There's kind of regional hubs. There's, as we can see from some of the kind of pulled the stats off the website today, there's loads of teacher resources that are kind of freely shared, kind of Creative Commons type stuff. There's a thriving discussion community, as you can imagine. There's the perils of any kind of forum, but there's some really interesting discussions about what's happening. And there's 200, nearly 250 hubs across the UK. So this is a really distributed model of trying to help and support teachers in their practice, bringing teachers together and letting them do stuff, do interesting things, and bringing people together who care about this stuff. So a part of that is a kind of network of excellence, which has been really in England, which has been funded by the Department for Education, but that's trying to bootstrap confidence and capability for the curriculum. And this is, so I suppose CAS, we don't try and own any of this stuff. I think part of the sort of reason of success has been around collaboration, and there are a number of people who are doing some really cool stuff. Obviously, people like Raspberry Pi, Code Club, there are a number of bodies who are doing some really, really cool stuff. And this is one of our kind of collaborations with Raspberry Pi and BCS, the professional body, just to try and, and again, this is free. If you can, this is a superb magazine, teaching resource. So yeah, have a look online and get the copies. So kind of more focused around the talk. So terminology once again. So this is, as we started to see curriculum reform happening in England, but more generally kind of there was a lot of focus, there was a lot of policy focus, there was a lot of economic and kind of industry focus on this. The phrase kind of the coding curriculum started to appear. And actually this seemed to be, as when people were discussing some of the potential curriculum reforms, and as they were happening, they always referred to it as the coding curriculum, or getting kids coding, or it was predicated on economic aspirations. So we need loads of coders for the economy, and this started to be a very consistent narrative. Certainly in England, especially kind of preparedness for the curriculum. There was a lot of essentially kind of parents' guides, so trying to inform parents about what was actually changing. Clearly, stuff has been happening all over the world. There is a number of countries. There's Estonia is a good example. Israel, a number of different states in the US have tried to do similar things. But arguably, England were one of the first to kind of formalize this from the age of 5 through to qualifications. But this has been a real kind of. There's basically been a lot of Medium posts where people saying, should we be teaching kids programming? Or a lot of thoughtful polemics and kind of monologues about whether we should be teaching young kids to code. Or what should be, or maybe more accurately, what should be the focus when we teach young people to code at school. And I think there's been either some sort of misinterpretations of essentially saying we are just trying to pump out programmers. So, at the age of 16 or 18, we would expect you to be able to, write your own Python library, or to be able to, straight away write merge sort from scratch in Python. But actually, that's certainly is a misunderstanding of what we're trying to do from general education across the UK. And again, there's a lot of stuff about the digital economy. I'm as guilty as anyone, especially kind of speaking to ministers and civil servants, when this is where you lay it on thick with regards to, this is very good for the digital economy. This is going to be high value skills for the knowledge economy. But actually, this is, it's interesting when you're talking in the context of emerging economic sectors, or you're talking about where there's going to be growth or the demands of certain types of skills. Clearly, these high-value, data-driven, programmatic, computational skills are in demand in pretty much every economic sector. So, banks, professional services, this isn't just the case of, for computer science degrees in particular, they think they're just going to be cutting code, in a dark room as a software engineer. Actually, everyone seems to be in demand of these, maybe not necessarily skills, but maybe the way that they think and frame problems, and that's going to kind of lead into some of the content as we go through the talk. So, policy levers, I know that's the sort of thing you want to hear in a talk at 9:45 in the morning. Let's talk about some policy. But essentially, this has been massively influential. This again, alongside the influential Royal Society report, senior industry people sort of lamenting the state of affairs from a curriculum perspective. So Eric Schmidt, he gave an influential talk. It was the McTaggart Lecture at the Edinburgh International TV Festival in 2011. He sits on, he was the kind of Prime Minister's sort of Science Advisory Council. Unsurprisingly, the exec chairman of Google can say things and people listen. But this was kind of based around more the sort of cultural heritage of the UK, to say, we used to be really good at this. We were the pioneers. You can kind of hark back to the days of you start talking about people like Turing and talk about Bletchley Park. But essentially you say, like, actually, some of the early kind of pioneering efforts, particularly both kind of hardware as well as kind of theoretical and software, were made in the UK, and we sort of lost that kind of step at some stage. And that was certainly reflected in the curriculum. There was a massive focus at the end of the 90s into the 2000s around basically creating competent users of technology. So rather than equipping young people with the skills to be creative and to make things, we were really worried about them being able to use kind of office productivity software. So they need to know how to use Word. They need to know how to maybe do a bit of stuff in Excel. They need to know how to do presentations in PowerPoint. And that seemed to be an overriding factor. That's a generalization, and there were some amazing things happening in schools, but that was largely the interpretation of the curriculum in the majority of schools. And that was quite damaging because, as you go through your school career, it kind of became the same sort of stuff year after year, and there wasn't a lot of progression as you went through. There was then a perception of the discipline was being quite low valued. It became it's just teaching them the skills. Maybe we can cut curriculum time because it's not that essential. The focus is on STEM, core subjects, English, maths, science. We need to give them the priority. And actually you might get an hour or a fortnight to do ICT. And this was a really big kind of pipeline problem. Obviously coming through to quals and to kind of post-compulsory education, so whatever people were doing after school, but also this seemed to have quite a significant effect on the diversity of the subject. So, basically it became a geeky boys subject, and that was really, really damaging. We're still in that kind of the mire of that problem right now. Again, two big influential reports, both of these this was certainly kind of economically driven, so this is by the sort of Nesta Next Gen report. This is looking at kind of creative economy, so where do we have these kind of high value skills for video games, special effects, computer graphics kind of industry, made a very clear recommendation about computer science education, and then the Royal Society report in 2012, which again said we need a reboot across the entire UK of how this is being taught in schools. Again, this is an editorial in the Times in 2012, but again, this is sort of flowery perhaps. But again, it sort of says, what do we want to achieve by teaching young people these skills? Are we trying to empower them to be creative in a digital world? Do we want them to have the ability to manipulate the world in which they genuinely live? So in the sense of, we kind of live, work, study, are entertained in a digital world. Actually, do we want to equip young people with the ability to manipulate, make, and break in that world, rather than just to be consumers of technology? So this is the sort of momentum was kicking up and was really kind of pushing forward around the time of curriculum reform. But essentially, this was maybe more of a societal imperative to say, actually, everyone needs these types of skills, kind of to understand the world in which they live. And also, yes, this is good for jobs. Yes, this is good for kind of future potential. But actually, this is about understanding and being a confident and capable citizen of our world. There are a lot of slightly meaningless declarations by the government. So, I would like to say, how would you measure the UK being the most digitally skilled nation? What's the internationally recognized unit of high value, digital skills? But actually, and I suppose this is another challenge of saying this is obviously from DCMS, but this is basically England because of kind of devolved funding nature. So that's an ambition, if anything, but kind of what does that mean as you kind of drill down? There's been a number of other influential reports which have all largely said the same thing. This is the Lords Select Committee on Digital Skills in 2015. This is the House of Commons Science and Tech Select Committee in 2016. This is the sort of language we're hearing. The evidence base says we have a massive digital skills crisis. And that is across the entire piece. That's not just what we would deem to be kind of these high value skills. We're basically saying this is just sort of competent and capable users. So kind of baseline digital competencies to understand the sort of tech we use every day. Then got followed up by another Lords Committee inquiry, which is more about kind of ease, safety, and I suppose think of the children, keeping them safe online. And then obviously this is all framed now more broadly in kind of the UK digital strategy, the UK kind of industrial strategy. So essentially, where are our key kind of growth sectors, or these kind of thematic, great technologies that the UK has ambitions to be really, really good at going forwards. And also the kind of what's the skills base and the talent pipeline to support this. Again, I'm not going to talk about Brexit like I did yesterday, but in the sense of this perhaps undermines some of our economic ambitions, but that's another time. The context. So it's interesting, one of the questions that kind of popped up yesterday to say, how do you make this relevant to young people? How do you kind of contextualize what we're trying to do? Why to speak to parents or to speak to the general public about why we're trying to do this type of stuff? Well, actually, this impacts and influences everyone's life on a day-to-day kind of nature, particularly around algorithms. That was a scary word that appeared in the program of study. You were supposed to teach the idea of algorithms from the age of 5. That's a recipe. That's a set of sequence of of instructions to achieve a specific task or goal. But actually, this shapes and influences the way we consume information. This changes. It makes decisions about us without any human intervention. So people need to know about this stuff. They need to have a bigger understanding of the impact it has on people's lives. Clearly, cyber, cyber, this is kind of like a buzzword that appears in pretty much everything. You can prepend it to pretty much everything, like digital, and it largely means nothing. But in the sense of, this is a clear economic resilience perspective, personal health, personal data, what are we doing with sharing our information? Is there explicit consent about doing this type of stuff? Who uses Facebook? Well, actually, thinking about to whom are you giving information, and is that a fair and kind of equitable exchange of resources? How does that affect legislation? In the sense of mass surveillance and data retention. That's never going to be a doorstep issue, but actually, people should be deeply concerned about overreach without much judicial oversight. Clearly, this has had a massive impact on certain large-scale political events, particularly our noble President Trump in the US and obviously Brexit. But in terms of how does information propagate over a social network? Well, actually, people just like things on Facebook, or they just share stuff that appeals to their beliefs. So actually, how do we shape and influence or inform or give people the ability to assess the credibility, veracity, and quality of information they receive online? Because people don't, certain demographics, particularly kind of younger people, don't buy newspapers. So how are they going to get their information? Largely how it propagates through the social networks that they're on. And again, then you have ministers of state saying silly things about encryption. So how do we make, when people say stuff like, we need magic backdoor keys to crypto systems because we need to look at all your messages, this becomes a digital rights kind of civil liberties issue. And actually we need a societal discussion about this, not to kind of say everyone should, I suppose it depends on your position and kind of, there is fair judicial oversight for some of this stuff. But just to say we should have, special access is an absurdity and kind of shows you don't understand how crypto works. Or even worse, you're trying to kind of ban mathematics, which is difficult. So that's the kind of broader societal context, and that's where there's the relevancy of why we're teaching this stuff in school. So it isn't just about saying, let's teach some stuff around, for many years I've taught first year kind of maths for computer science at university level. Why do we teach people propositional logic, number theory, and set theory? It's not because we can't think of a 20-credit module in the first year. It's because this stuff frames our understanding of the foundations of computer science. So that's why we teach about kind of prime numbers and number theory, because it gives them an understanding of crypto and the complexities of doing real-world things. But actually, that's how we can make some of this. That's how we can make the relevancy of what we're teaching in schools much clearer. But actually, how that's being taught and the resources to support that is patchy and uneven at best. So back to terminology and kind of what's been happening. So as sort of ICT, this subject was in school, it was disaggregated. I'm not sure if that's actually a word, but it seems to have appeared and is being frequently used. But decomposed, perhaps maybe that's a better example, to pull apart the key themes within ICT and say, well, actually, some of this is around digital literacy or digital competencies, and this is a cross-curricular thing like literacy and numeracy. Then you have something that is being called IT, and then you have this kind of rigorous and well-established discipline called computer science. So some of it's maybe IT is kind of a bit more socio-technical and talks about kind of people and systems and how to make things work in the real world, and that's not IT user skills, that's understanding about kind of requirements and solving problems, and then you've got this discipline of computer science, and it's all kind of framed across curricula with developing these digital competencies and IT user skills. That was proposed in the Royal Society report in 2012, and actually this has been, I suppose, the kind of aims of the curriculum, and this has been perhaps unevenly implemented in England. I'd say that's probably much closer to what we're doing in Wales now, but there's probably been much more focus on computer science, perhaps to the detriment of these two things. I just want to briefly kind of cut through, this is a 3-page document. If you've never read the program of study, why would you? But if this is a 3-page doc, which basically, for the programs of study in England, which basically says at each key stage level, this is what young people should be able to do. On successful completion of this key stage, you should be able to do this. And these are the high-level aims of the curriculum. So essentially it says, we are talking about key principles of computer science. We are talking about, computational thinking skills. So, we can analyze real-world problems in a, kind of assess them and deconstruct them in a kind of a data-driven computational way to solve real-world problems. And actually, we have an understanding of kind of applying real-world technologies to solving these problems. And actually, there's this kind of bigger legal, social, ethical, professional approach of, framing everything that we do with technology, with computing, rather than it just being, let's write some code. And so I think that's a nice kind of ambition for what the curriculum is aiming to achieve in England. And this is the first line. So remember, this was written, I suppose, well, by some of us, but in the sense of this was written for a civil servant. But this was the ambition. A high-quality computing education equips pupils to use computational thinking and creativity to understand and change the world. That's a bit hyperbole, but that's essentially what we're trying to do. We want them to actually have the ability to manipulate and influence the world in which they live. So it isn't just purely about tech. It's giving them the creative skills to do fun and interesting and maybe important and impactful things, both at school and obviously as they go forward in life. There's a big focus on computational thinking. Who's heard of the phrase computational thinking? Okay, well, there's a very dry definition for you to absorb. I like the phrase information processing agent. I'm going to use that more frequently when I refer to other human beings. But in the sense of this is kind of a de facto, I mean, this is a really key phrase in the context of talking about computer science curricula across the world. Maybe this is just a rebadged version of things like algorithmic thinking, kind of mathematical reasoning, but actually computational thinking is essentially deconstructing the world and thinking about it as a computational agent, I suppose. And this is a key aspect of pretty much every computing curriculum that's appearing, particularly when there's any kind of substantial digital skills reform. There's a lot of focus on programming, and there's a lot of focus on computational thinking. And actually, they seem to be, they are clearly intertwined and sort of co-related. So actually, maybe we're talking about both of them at the same time. So we're not just trying to teach people how to program. It's about equipping them with tractable, problem-solving, kind of computational thinking skills that can be used across the curriculum and essentially for whatever you do. But it's quite challenging. Again, there's a lot of terminology kind of thrown around with sort of CT stuff. These are the sort of phrases you might have seen in the context of if you've done a computer science degree, but also just in the sense of these things are kind of, these appear in a number of different guises, in a number of different ways when we're talking about programming. So, understanding what we're trying to do, assessing the complexity of problems, can we parallelize, can we distribute, can we decompose them, can we make them simpler, can we abstract them, can we understand, can we generalize the problem and make it easier to solve? And this stuff appears in Key Stage 1. So if you're not familiar with kind of UK terminology, or rather English terminology, then this is the sort of stuff you would be starting at the age of 5, so kind of going up to 8 or 9, and this is what you would expect to be doing in primary school. So when young people, they're at primary schools, largely taught by non-subject specialists. So this is the sort of stuff they would be doing. Some of this stuff they've been doing for a long time, but actually, when you see things like, for many, hearing the phrase algorithms was a bit scary. Actually doing proper programming, largely kind of visual programming, kind of block-based programming, things like Scratch. But actually, applying, a bit of logic, you kind of see the mathematics kind of underpinning here. But then, this was the stuff that was largely everyone was quite comfortable with before, particularly, kind of using technology. But then there was a whole kind of chunk of real substantive change of the kind of the balance of the curriculum in primary schools, and this was really disruptive when this first appeared. But actually, when we've tried to kind of articulate what we've been trying to do with computational thinking, is this is where we talk about it as a cross-curricular skill. So in the sense of we are trying to get young people to understand complexity. We are trying to get them to understand about persistence and dealing with ambiguity and kind of reasoning with incomplete information, I suppose, and have the ability to understand and solve open-ended problems, rather than saying, here is a very specific problem, once I teach you the trick for solving the problem, you'll always remember it, but you won't ever be able to use that knowledge to solve other problems because it's so very specific to that problem. And again, we see the kind of general purpose nature stuff like, the ability to work in a team. So actually, that is essentially kind of an aspect of some of the CT stuff. Some of the challenges of teaching programming in schools. So I know there's going to be a number of teachers here, and it'd be interesting to hear some of your kind of comments and questions at the end as well. But the criticism of saying, well, not everyone needs to learn how to program. I think it features as part of general education. It's an aspect of, we live in a world that's dominated by software, so it seems to be a fairly reasonable thing to teach people a bit of how to make some software or to understand how software is made or how computers do things. Do we teach problem solving? That's still a kind of, I think that's an ambition, but that's still an open question. Big discussions about which languages we choose first. So Python has probably become the de facto language primarily because of the qualifications that have appeared and the resources around it. But again, there's a lot of languages are taught in schools. Are they all suitable? Maybe. Historically, there's been a lot of things like VB kicking around, but there's, Java appears a lot. Obviously, a lot of kind of web dev type languages. We even know there's some people teaching Haskell and other kind of functional programming languages in schools, which is, while it's an you can link it nicely to maths. You can actually have an understanding of like how you solve problems in a different way of kind of writing programs. But actually, I think Python has become certainly a very, very common language in UK schools. The challenge of depth versus breadth, so, do we teach more than one language? Well, you kind of have to because of the curriculum, so kind of moving from a visual language to more kind of a Python type language. But then, do we teach tools and IDEs? Should we teach them, should we get them good practice and get them using version control and use things like GitHub? What about creating useful and usable software? Well, that's a massive ambition for what might be only a few hours a week in schools. So, but how do we get them to think about this bigger picture, this bigger problem of it's not just about kind of maybe copying a bit of code off the board and actually not really understanding about what you're doing, or understanding the complexities of syntax and semantics of a specific programming language. The key thing has been kind of real-world context, so actually nurturing curiosity and giving people the opportunity to identify things that they care about and then maybe do project-based learning around kind of their personal interests, and that can be very, very broad. It makes it, you don't have to say, let's do a very specific project on this thing and everyone has to do the same thing. If you're interested in sport, music, whatever, you can actually use this to kind of guide, find an interesting problem and try and solve it programmatically. Some of the kind of pedagogic approaches, it's daunting, kind of staring at a blank screen, having to write the first bit of code. So actually, how do we start to build on that kind of code literacy aspect? So, reading and interpreting existing code, and actually then, kind of refining slightly broken code, or actually kind of, working with existing code bases rather than saying, here's your blank IDE, write your first program, beyond kind of a, print hello world type thing. Again, things like pair programming have been really, really effective in schools. So actually, how can you kind of get teams of people to work together collaboratively to solve a problem, and then to kind of reflect on that approach and how, especially when you've got, real diversity of ability in a classroom, how do you kind of take advantage of some of the students who might actually be extremely gifted programmers? But actually, this thing about failure is a really key thing. It's very difficult to teach and reinforce, or to give an environment and where it's well received. But actually, if you've ever programmed, I mean, imagine most of you have, then unless you are amazing, you don't write perfect code the first time. So actually, you're going to make mistakes. And actually, how does that form part of the learning process? And how do you not get daunted by, well, you just cannot interpret the kind of, the lengthy error messages that are turned up, that are kind of produced by, a syntactic or a semantic error in your code. So actually, building in that resilience, again, at some of the computational thinking stuff. But that's hard to do in schools when you've got a real kind of mixed ability group, or people's first taste in programming. They can be quite daunted by some of the challenges. But this is a key. I suppose this is the kind of current priority now, is how are we developing these effective pedagogies for teachers, or this is a kind of an educational research problem. Is what's the best approach for from a learning and teaching perspective? So effective pedagogies, and how do we effectively assess progression? So how do we teach this stuff, and how do we assess it properly? And that's a challenge across, from the age of 5 through to when you're doing this at degree level. Writing effective programming assessments. I can, having written 2-hour exams on programming, that's probably not the entire way to assess people's kind of programming ability or their understanding of principles of programming. So there's a number. I just wanted to kind of go through a number of resources which might be of interest for you to have a look at, and these are really good examples. So CSUnplugged is a fantastic resource, and essentially it's computer science without a computer. This is developed by some academics in New Zealand, and this has had a significant kind of worldwide impact on how some CT, computational thinking stuff, has been taught in schools, but how you can introduce CS at primary school. Have a look at the website, have a look at some examples. Essentially, you can do, teaching algorithms. Well, do it in PE. You can then do kind of sorting algorithms and get them to run around a hall and kind of to follow some instructions that are kind of drawn in chalk on the floor, and get them to think about algorithms and making decisions and basically kind of stepping through a program, and then they eventually end up being sorted as they go through. So the diversity of examples is huge, and it's a fantastic resource, and that's had massive impact in UK schools certainly, but that's a very, very kind of established approach. apologies for the quality of the logo, but this is an activity that's been funded by BT, which looks at some of the kind of programming computational thinking approaches, so actually getting young people and having a wealth of resources to support delivering some of these ideas. You can see some of the kind of computational thinking and programming stuff here, and again, delivering some of the CS key concepts. Again, sort of this is very, very broad. It's not just kind of talking about, just pure CS fundamentals. It's talking about kind of broader societal impact of this stuff too. QuickStart, so this is, again, building on, we have a massive focus on the CPD and kind of professional development of teachers. So how can we support subject knowledge enhancement and giving them the confidence and capability to do stuff? So this is another good example, funded by DFE and Microsoft. This was funded by Google, so this is supporting professional development of teachers in primary schools. So remember, these are non-subject specialists. They might have, they have a degree in anything, basically. There are very, very few primary school teachers who have a degree in computer science. So actually, how do we develop their confidence and capability to deliver some of the sort of key stage 1 and 2 curriculum? And this is a massive focus at the moment about effective assessment. So how do we, if we're teaching all this stuff to kids, how do we test their knowledge? So, rather than just giving them an exam or giving them, here's a programming task, you've got 20 hours of supervised time to do it, how do we test their subject knowledge? So do they actually understand, an algorithmic problem? Do they understand, can they give an example of decomposition or abstraction? Do they understand sort of, a key idea within object-oriented programming? Could they describe a sorting algorithm? Well, actually, this is a key focus with some academics from Durham around how do we test this knowledge in school? So this isn't about formal, GCSEs and A-levels and equivalent qualifications. This is about testing progression through a school year and seeing whether the impact of your teaching is effective. And again, you can log on and see the corpus of questions. This is a massively valuable resource for anyone to kind of see how we trying to get to have a really rigorous approach to developing effective assessment in computer science and programming. And then it's kind of more fun stuff. So there are international kind of competitions. So this is something called the Bebras. So this is the International Challenge on Informatics and Computational Thinking. And actually, there's an increasing number of UK schools kind of take part in this. But actually, this is a thriving kind of annual competition across the world for, I suppose, if any of you has had the pleasure of doing international mathematics kind of Olympiads or international programming competitions. This is another example for kind of getting kids to sort of challenge-based kind of problem-based to apply their knowledge of their subject to solving interesting problems. And there's one they can win prizes and they can kind of engage with other teams across the world and other schools across the world. So it's it's very fun as well. This is another thing. So I suppose that's the kind of context of what's been happening and kind of where we are now. And I suppose that certainly it doesn't really highlight some of the kind of bigger challenges that we have in scaling and kind of building the curriculum in England. I'm just going to briefly talk about what's kind of happening in Wales, I suppose, to kind of contextualise, perhaps a different approach on a national level. So I've been largely involved in the ICT kind of reforms in Wales. So I chaired the review for the Welsh Government in 2013. I chaired this new digital competence framework that's been made available to all schools from September 16. And this is, I suppose, this kind of goes back to some of the stuff about the Royal Society report about if we're going to deconstruct or kind of decompose or disaggregate ICT as it is, what do we value? What do we think are core digital competencies for young people? So that's not the kind of myth of the digital native. I'm not saying there's any intrinsic digital competency because young people are used to using technology, but actually, what would we expect young people to be able to do as they go through, and actually as that would scale through and as that baseline would change kind of over the next 5 to 10 years. And this is what we've done with the new digital competence framework in Wales. And actually, as you can see, we say that data literacy and computational thinking are cross-curricular digital competencies. And this is separate to what's happening with the computer science curriculum. So everyone will be doing this kind of stuff alongside literacy and numeracy as these 3 cross-curricular priorities in schools in Wales. So as you can see, it's broadly defined. So, kind of digital citizenship. So what does it mean about understanding about digital rights and being a citizenship and, content, making and creating and, doing stuff online or doing stuff in a digital world. But actually, this is about solving problems and understanding understanding the world in the kind of data-driven and computational way. And that's been available to schools from September 16. So we're kind of seeing this being implemented as wider kind of large-scale curriculum reforms. But that's a dramatic reposition of these types of skills. So, we want young people to be data literate. We want them to have an understanding of what that means in the context of both, kind of solving problems across the curriculum, so just as much as in science as it is in PE and history, but actually, what does that mean in the context of being a digital citizen or being a citizen in a digital world? So, personal data. Yes, it's about being safe online and, appropriate behavior online, but actually it's about kind of, what are your rights? What's the idea of being a young person online? What would that entail in actually being part of that discussion and, the idea of being a confident and capable, digitally competent and capable citizen, I suppose. And that's been kind of framed by, so this is some of the stuff that I'm kind of leading now around this new kind of national network of excellence in science and tech. So this is where the computer science stuff is going to sit. And so basically computer science now will be joined by physics, chemistry and biology and design and tech in this new area of learning and experience. So essentially it's going to be much more interdisciplinary and cross-curricular anyway by these areas of learning and experience. But essentially this is probably a good way to think about those subjects. So rather than thinking about them as single siloed subjects, well actually, a lot of interesting real world problems are not just physics problems or not just kind of biology problems. They are increasingly interdisciplinary and require a bigger kind of, how do you think about understanding them and perhaps kind of developing knowledge in them and also kind of solving them. And maybe, reflecting on what you may want to do and study in the future. So actually understanding that if you want to be a scientist or an engineer, or you want to study science engineering after you leave school or to do a job in that area, well actually largely you need computational skills and you definitely need programming skills. So actually how does that kind of frame kind of what you want to achieve and what you want to do in the future? So kind of tying it all together and hopefully kind of leaving some time for questions. This is the third instance, so we're in the third year of the, actually we're in the fourth, I think we are in the fourth year now, of the new computing curriculum in England. This is in the context of wider curriculum reforms both across the 4 nations of the UK, but in a lot of other countries across the world. So there's been a lot of scrutiny of what's been happening in England, especially the effectiveness and the kind of interventions to support it, but actually, basically people are trying to do very, very similar things with a range of different resources and a range of different kind of cultural and economic contexts. This has probably been a byproduct of very, very successful kind of policy work, which sounds really dull, but that's the way it happened so quickly. You had to get buy-in from ministers and senior civil servants to make this happen so quickly. But also this kind of broader stakeholder engagement. There's a lot of different levels of people who care about this stuff, but also are directly involved in its success. So how do you get those people on board as part of a kind of co-creation, kind of co-implementation model? There's been a lot of funding, particularly about kind of developing these sort of various communities of practice. So the idea of a network of excellence, how do we support that distributed model for supporting teachers across the UK? Largely now it's moved from a kind of strategic policy thing to a proper hands-on, operational implementation phase. So what are teachers doing? What do they need? What are they worried about? How can we best support them kind of going forwards? And again, this is about, I suppose as you can see from the kind of thriving discussions on the CAS forum or fora, how do we kind of share and capture and identify best practice and support kind of basically continuous improvement kind of going forwards. But it is still about reinforcing that message about there's, historically a lot of the kind of things that have dominated the discussion has been around kit and technology. So, schools buying iPads or, what do we need to give teachers kit in schools? Or it's just been about programming, what languages they're using in schools. But actually, how do we build that bigger message about computing and computational thinking is for everyone. Everyone needs to understand it and be exposed to it at school and have the ability to choose qualifications and maybe to go on to do whatever they want going forwards. And particularly reflecting on the broader kind of diversity, particularly gender, and actually making this as an inclusive subject and not stopping people from getting involved. You know, if girls are put off at the age of 11 onwards, then we can't lament the kind of gender and diversity problem in the industry when we know that we're putting them off when they're at school. So how do we address that, and what type of interventions are effective? So looking ahead, I mean, as you can imagine, 3 years into a curriculum, and obviously at the cusp of curriculum reform in Wales, this is not completely fixed or completely solved. I mean, it's the end of the beginning, I suppose, and actually kind of looking forward about how do we scale that operationally kind of going forwards. The utmost priority is about CPD for teachers and how do we support their subject knowledge, but actually given it in a way that is good for them, is accessible, hopefully doesn't cost too much, or even better, is free. This is where the big sell to you lot is going to come in soon, so how you can help going forwards. Particularly recruiting and retaining teachers. I think there is not a fight. We can talk about salaries, or we can talk about kind of bursaries to attract teachers into the profession, but you aren't going to compete with a well-paid software job in industry. You aren't going to compete with basically becoming a quant in a bank, because you can get paid a lot more money doing that if you're a very, very gifted mathematician or programmer. But actually attracting the right kind of people who kind of care about teaching in schools, and also incentivizing their development and making sure they stay in the profession. There is a massive focus on identifying and sharing effective pedagogies. There is another Royal Society report coming out in about a week's time, which I am pretty sure will make some very, very clear recommendations about the evidence base and the research base and the capability in UK universities to support this curriculum from an educational research perspective. But actually, how do we make that accessible to teachers? How do teachers access research and emerging and effective pedagogy? So how can they access this type of knowledge, and how can that shape and influence their practice? Better understanding assessment and progression. So we're not just testing kind of 2 or 3 hour exams. How do we do practical stuff? How do we develop kind of in-year assessments, and particularly some of that work with Project Quantum, and looking at kind of depth, breadth, and creativity. We don't want this to turn, because of it becomes a very prescriptive kind of top-down implementation. We don't want this to become what is perceived to be a hard and dull subject at school, because we would have failed in the most kind of brilliant way from what we had said that ICT was perhaps quite dull and boring at school. And actually then we've managed to turn a massive opportunity to change this subject, and then we fail because it's also become very, very dull and boring. There's a massive focus on computational thinking, so how do we kind of look at that in the bigger context of effective approaches to developing computational thinking skills, especially across the curriculum. That's certainly happening in Wales, but how do we kind of, that's not just talking about computing teachers in schools, that's essentially talking about every teacher in school. How do we get PE teachers, history teachers, geography teachers to think about, this is relevant to me and relevant to what I'm teaching as part of my subject. But this is still a massive problem, particularly, I suppose, in comparison to other science subjects. I think there is certainly a badge of honor about being a nerd and being a geek and kind of being geeky. But actually, there's still a very, very poor perception of this type of stuff, particularly with the general public, but also with parents who can be very influential about their children's kind of what they want to study and what they want to do going forwards. So, people, maybe it's kind of a cliche that, parents probably want their kids to be, like doctors and lawyers and traditional kind of professional disciplines. Do they want their kids to study computer science or to do engineering? Maybe. Do they recognize that there might be a diverse, there's huge opportunities from studying these things at school or doing these things, in a range of different careers, but actually, maybe they're like, you're just going to be a programmer. It's like, well, so what? That sounds actually quite fun. You can be a programmer in pretty much any economic sector. one, you can get paid usually quite well, but actually you can actually solve some really interesting problems. So how do we explain and articulate that to the general public to understand that it isn't just about, you know, the next £1,000 iPhone 10. This certainly isn't it, by the way. And and you know, it's not just about the next kind of shiny bit of consumer technology. This is about, you know, this gives us some really interesting thing to solve some big sort of societal kind of grand challenging problems. But I suppose it reflects back to the kind of CAS motto, and this is my final kind of sell to everyone here. If you care about this stuff, you might have children at school, you might care about this because this is your job, or you just care about this thing being, you recognize this being important to, you know, you're being altruistic and saying this is for the greater good, please get involved. There are schools, there are teachers who are genuinely open and receptive to your help, and there are a range of different ways in which you can help out. So it makes no difference, you know, if you've got knowledge and experience and the time to commit to helping support this kind of stuff in schools, then, you know, code clubs, join CAS, help out your local school, volunteer, you know, just to kind of get involved and to kind of share and change the perception of this subject. And I think, you know, we are at the cusp of, you know, things are changing. It's been disruptive, it's been a bit painful, it's happened very, very quickly, but actually this is a massive opportunity to kind of equip young people with, you know, to make them digitally competent and capable, and, you know, to better understand the world in which they live. And, you know, maybe this will hold politicians to account when they say stupid things about encryption going forwards. Thank you. All okay? It must be good, everyone's leaving. I must be right, I must be right.
Yeah, I'm very bad at hardware. We've got a few questions from here.
Thank you very much. So how much involvement have you had with Code Club people?
With who, sorry?
How much involvement have you had with the Code Club people?
Yeah, so a lot. I mean, I think kind of CAS and obviously we work very closely with Raspberry Pi and Code Club anyway. And I think, one, they do fantastic stuff, but I suppose the challenge is about the distribution of Code Club across the UK. So obviously, you know, where there's population density, it's easy. I mean, in Wales, it's really, really challenging. So there's some code clubs in southeast Wales, around kind of Cardiff's, you know, obviously in where there's the population density, but in mid-west Wales, in northwest Wales, it's really, really hard to get code clubs happening. So, you know, that's basically, we need volunteers all over the place to help and support that stuff. But, you know, that's the model. That's a really well-established way of kind of getting in and helping schools. So, yeah, please, you know, join a code club. That's a great opportunity.
It's very fun. I recommend it.
There we go. Perfect.
Any more questions?
Thanks. So, Tom, you mentioned giving kit to schools,
yep.
and that schools often have iPads and so on, possibly, you know, 5 per school or something in some cases. Is there any merit to thinking about giving, you know, a class set of microbits or something to every school in Wales, or along with all the CPD stuff needed to go with them, or is that not worth the money?
No, I mean, I think that is a great question because, I mean, schools obviously have some budget for stuff, but obviously it's never enough. And obviously some schools are better resourced than others for particular reasons. I mean, obviously the BBC did, as part of their kind of year of code stuff, they gave every year 7 pupil microbit. I mean, I suppose the challenge of doing that without the kind of confidence and the capability and the resources to effectively use it, I imagine there are a lot of microbits sitting on shelves, or they're just not being used, or they were broken, and you know, it was great for a couple of weeks because there was, you know, a real kind of focus and momentum of when it was launched. But actually, what does that mean? I think, you know, for example, if you gave a number of Raspberry Pi, like a class set of Raspberry Pis to a school, that would be fantastic. As long as there was a range of, you know, or you know, vendor neutral, you know, Arduino, whatever you want to give them. Then, you know, as long as there's the resources and the sort of sustained support to make sure it's effectively used and it's contextualized to what they're delivering as part of the curriculum, then that's really, really useful. but I think it's necessary but not sufficient, I suppose. I think you need that as part of, I think the more effective interventions in the short term are going to be around CPD for teachers, professional development, and subject knowledge support.
Okay, we've got time for 2 more quick questions and quite quick answers. So.
Noted.
So a quick question. Some of the people we speak to now are wondering if, with the kind of first victory on computer science being in the curriculum, it's time to start differentiating between computer science and software engineering as 2 separate skills. Is it time yet? Is it something we should ever do?
Great question. Possibly going forwards. I mean, I suppose it'd be interesting to see how effective, how much software engineering in the bigger sense you could teach in schools in a couple of hours a week, or if not everyone does a GCSE in computer science or a A-level in computer science. I mean, think about if you go and study computer science at university, then the diversity of incoming undergraduates is from people who have literally never done any programming ever, so they might be really good at maths or they just like the subject, to people who might have done 4 years, 2 qualifications, they might be gifted programmers, they might have their, look at their GitHub repo, they might have contributed to open source projects. So that is the breadth of challenge we have at university. I think we need to think about what software engineering entails in schools, whether that would be separate qualifications, whether that would be differentiating the subject. I think it's unlikely because there's too many subjects as it is at school anyway. Creating another one won't be very, very helpful. But I think we can reinforce the fact that it's certainly separate from computer science, and there are certain skill sets that we need to focus on. UX and stuff never appear, or creating useful and usable software, for example. But yes, that's something we're definitely going to consider as it matures going forwards.
Okay, before the last question, is Scott here for the next talk?
I'll answer that one. I don't know, I can't see it.
Hello, Tom. Gareth from the Microbit Foundation.
Hello.
So actually, just wanted to pick up on that point that you made, because we're actually getting a lot of countries coming to us now saying, can we emulate what the BBC did? And our response has been, yes. But if you do so, it has to be a lot more targeted. It has to be a lot more effectively supported. If you're going through the schools, you need to have that framework of curriculum materials, teacher CPD, support network in place to make sure it's properly embedded. Otherwise, you will end up with a situation where things are sat on the shelves. Yeah. But actually, what my question was a lot of the stuff that you've been talking about here reflects very well on the attitude that we're taking forward with the foundation. But one of the things that we're finding out as we go around the world is there's all sorts of different takes happening upon this. And one of the things that's been interesting is looking at what's happening in China and other areas where they're focusing on skills development rather than content knowledge, and also on maker education. Yep. And I was wondering if you had any words about that.
Yeah, no, and that's very, very true. So I've been in Taiwan and Hong Kong over the past kind of 6 months, and it's interesting seeing their curriculum approaches, because Hong Kong, for example, are unlikely to have a substantial curriculum change like is happening in the UK, but they're very much focusing on skills. So they very much about computational thinking, very much about kind of programming and doing things and making things. So maybe that's an artifact of their kind of education system, but I think maybe they'll realise the benefits a lot quicker, because it's about specific kind of cross-curricular targeted interventions rather than complete curriculum reform is a monster, as you full well know, and it can be culturally difficult as well as kind of actually once you've got the curriculum in place, it's not solved, I suppose. But yeah, I think that's the maker culture stuff is a big angle and changes the perception of some of this stuff and makes it much more real as well. Thank you. Good luck.